December15 quiz that I just handed back to you. We do want to go ahead and get some questions on question number 4. That was the last question. So are there any other questions besides the last one that you wanted to talk about or go over at all?
Number 3.
Number 3. Number 3 was a tree diagram question. I was looking for a tree diagram. I gave you 3 points for the tree diagram there, and an additional 3 points for the correct answer. So let's just go ahead and do question 3. It's a great question to know that a tree diagram is important to do. What tells us in the problem that we should do a tree diagram, by the way? There's multiple things, right? Multiple things going on. You could be sophomore, junior, senior, whatever, the grade level is one. And then what was the other thing? What their major was. It was like a humanities major or not a humanities major, right? So we have 2 levels or 2 branches, so to speak. So let's start with, I don't know, 9th, 10th, 11th, and 12th grade. Does that seem reasonable? And then from there, we'll do a different branch that you're either a humanities or you're not a humanities. Does that seem reasonable to you? Is that what you guys did with your tree diagram? Something similar. It doesn't have to be exactly in this order, but you could have done like 12, 10, 12, 11. You could have done these in any order. Let's put the numbers on it. So it says 22.5% are seniors. So 0.225. And then we have 25 are juniors. We have 25 are sophomores. And the rest are freshmen. So what would the rest be? Yeah, 27.5. Good. Or 22.275. Excellent. Then the second branch says 40% of the seniors major in humanities. That means that 60% do not major in humanities. Remember, each of the branches must add to be 1. And I'll just fill in the rest of the branch so we get the idea. 39% of humanities if they're a junior, which means, 61 is not. 10th grade, I have 40% and 60%. And then 9th grade, I have 36% and 64. Okay? Now, my tree is not complete yet. What else do I need to do? Multiply them to find 9th grade and humanities, 9th grade and not humanities. Basically, you're getting all of these numbers out here. For time's sake, I'm not going to do all of them. I'm just going to do the ones I think I need, if that's okay. So let's see. It says, what is the probability that a randomly selected humanities major is a junior? So, what is the probability? Let me write it down here a little bit. So we read again. What is the probability that a given humanities major is a junior? So aren't I looking at this, the conditional probability, correct? The order of that is extremely important. It must be in this order. So knowing our knowing the formula that we need to write here, we're going to say the probability of junior and humanities divided by the probability of humanities. Good. So since we're looking at the probability of humanities, these are the ones I'm going to have to be able to do. I'm going to have to do all of the humanities major ones, aren't I? And add those together, and that'll be my denominator. So probability of humanities was, let's see, senior in humanities, I'm just going to write it in different colors. So senior in humanities was sorry, the key was wrong in the book, but double checking, 0.09, does that sound right? Okay, so 0.09 here, 11th in humanities, I have 0.0975, okay, and then 10th grade in humanities, 0.1, okay, and then 9th grade was the one that was wrong in the book, and I have 0.27, is what I got. The book got 0.09, 0.27 though, right? Yeah.
I got 0.09.
Let's double check. So 0.275 times 0.36. Can someone multiply those together for me? What'd you get? 0.275 times 0.36. 0.099. Okay, interesting. Well, the book was wrong and I was wrong. Okay, so 0.099. Oh yeah, it's right there, but not there. Did you find it? Where was it? All right, so we're going to add all those together, and that's what we're going to be dividing by. So when we add them all together, And then the probability of the numerator is just junior and humanities, which happens to be 0.0975. And then when I divide those, you should get 0.2523. That's your thing. The important thing is to know, A, can you read the question and know the order of the conditional? A, can you recognize the conditional? B, do you know the order of the conditional? Write the formula in context, show me how you got your numbers, and then show me what you divided by. Okay? Very typical question. You'll have one like it on your test on Wednesday. I'm not going to tell you to make a tree diagram, but you'll need to know that's the process. Okay.
Well, we always have to find every single probability at the very end when you one question. We have to find every single one, or can you just find the one?
Can you do what I did? What you're asking me? I'm trying to answer it fairly. I think I want you to do the whole thing. Just because I think by completing your tree diagram in the beginning before you even do anything else, then you have to go back and know what you need to pick from. I do want you to do the whole thing. Okay? You know, that seems like, I'm not trying to be mean, but I do. So I'm going to give you credit for the tree and then credit for the, you know, yeah. Which was just the sum of all those things I highlighted, all the humanities ones together. Okay. Anything else on question 3? Okay, let's look at the question. Oh, yeah.
Did you ever get a tree diagram and like go to
I've never seen one where you have a third step. Not at this level. They exist, obviously, if you have more than one thing going on. But then you're introducing a lot more factors and a lot more different things that can be evolved beyond our scope. Good question. Good question. Okay, let's look at question 1 real quick. Question 1 was another conditional distribution, but the order of that one was ham, given, turkey. So I think if you missed it, you did the order backwards. Did you do ham, given, turkey? Yes, this is what is the probability that a randomly selected family having turkey had ham at their holiday meal? So it's ham, given, turkey. And then you would do the same thing you did here, do the context and look at there. Okay? Anything else from the front? Okay, then let's look at the back. Question number 4, which I have as 3, but it is question 4. Okay. Actually, question C and C and D were the same. I'm sorry, C and E were the same question. And a couple of you came up to me and said, I can't, in my brain, I forget who it was, I think it was Devin maybe, said, I can't in my brain understand why they're the same, why would you ask me the same question twice? Well, it's just the wording. I want to make sure you understood that they were both conditional questions, and they just were worded a little bit differently, but they, in the end, gave you the same answer. So let me read what the answers were on that, so you can kind of check your answers, okay? So 3A was 0.601, B was 0.577, C was 0.628, D was 0.654, E was 0.628, and F, well, that was an independent situation. They're not independent, by the way. They were dependent. And there was multiple ways to answer that. But you'll have an independent question on your test on Wednesday as well. Which ones did you, I don't remember which ones you said. D was 0.654, and E was 0.628. Which ones did you want to go over on those? I'm sorry. Which one, baby? E. Okay? So let's look at that one. So, I keep on the right place. 4E. So it says, what is the probability that a randomly selected student ate breakfast given that the student is female? So we're really looking at this. They ate breakfast given that they're female. Well, what is this? This is the probability of breakfast and female divided by the probability of female. So we can put those numbers in here. Here. So we have breakfast and female was 125. Would you agree? Look at the numbers in there. If we're doing 125, you can divide it by the total, which was 331. That's fine. And then probability of female was 199 out. Sorry, female, right? Make sure I'm doing that right. Yeah, 199, again divided by 331. Since they're both divided by 331, you can just say 125 over 199, and then when you divide those, you get 0.62. Okay. Right back. Yes. There's so many different ways to do F to show independence. I'll show you the one way I did it, okay? So what I said was, if you're trying to show independence, and I just did this one, I know that the probability of breakfast given female, we're going to ask that, is that the same thing as the probability of what? Breakfast. That's what I did on mine. Again, there's other ways to check, but these would have to be equal if they were independent, okay? So we already know that this is 0.628. Earlier in the question, I think part B, didn't it say what's the probability that a student ate breakfast? So that was 191 over 331. And when I divide those out, I get 0.577, which is not the same as 0.628. So since they're not congruent, I'm teaching geometry, sorry. Since they're not equal to each other, we're going to say that they're not independent. They're dependent. Again, that's just one of many ways to. How many points? 2. They were all 2 points on the back. The only one, and everything was 2 points except for question 3 was worth 6. 3 for the tree diagram and 3 for the conditional work. Anything else?
Isn't that 4D?
For D was what? 0.654. 125 divided by 191.
What's C and E?
C as in cookie, and E as in elephant for the same answer.
Oh, okay.
CD is hard to see the 9.2. Right, so you have a chapter 14 quiz, you have a chapter 15 quiz, right? You've given them both back to you now. You also have a probability practice that was graded. I gave that to you as well. And then you also had a probability practice test, right? That I gave you. I don't think I graded it. It was like a homework grade. Now, Brenda, which one did I have you skip? Do you remember? It was like 2 through 5, okay? So we can look at those towards the end of class today if you'd like to. Make sure we have everything covered. We're no questions and we're good. Okay? All right. I'd like to go ahead and just go over probability distributions a little bit more to make sure that we fully understand them. But I'm going to go ahead and check for homework first. So if you'll get that out, I'm looking for the just checking in questions 1 and 2. Okay? So I wanted to just kind of recap a little bit about what we did during supplemental period last time about what a probability distribution was. Your homework, I graded number 2B. It was 280. I'm looking for the mean of that probability distribution. So many of you got 6s on that, which was awesome. Did you guys have any curiosity? Did you do it by hand or did you do it using a calculator? Hand calculator. They both work. Let's just make sure we understand how to do both in case when a quiz or a test I ask you to do it by hand. Make sure you know. Not yet. I'll kind of tell you what we need to write down and what's important as we go through, okay? So we already know what a probability distribution is. We looked at it during flex or supplemental, whatever we're calling it these days, last week. It's kind of a little table that talks about all the different possible outcomes and the probabilities of each of those outcomes. And I think that the one that we did in class was number 6 on one of the probability practices that we did. Was the coin problem? The 2 coins that fell out of your pocket, if you guys remember them now? And so we had to come up with those probabilities, and that is by far the most difficult one you would ever see. And on the quiz or on the test on Wednesday, I'm not going to ask you to come up with something like that by hand, okay? We'll do more of those after winter break a little bit, and we'll look at what we call binomial and geometric situations then. But for now, I just want you to be able to know what should all the probabilities add up to be? 1. So we know that all the possible outcomes and their probabilities. We talk about random variables. We're going to talk more about that after winter break. Because I think in chapter 16, when you read it, it talks talked a lot about taking two random variables and adding them together, or multiplying by a constant. They had all these different formulas. Is that correct when you were reading through chapter 16? We're going to take that, Tanner. Eyeballs, thank you. Oh, too much. Wake up. You want to come sit far? Tanner, in the cushy chair. If anybody's sitting in the chair, it's free for whoever wants to sit. All right, so we know here that is what a probability distribution looks like. So let's just kind of fill in what we know at this point. We have a number of new cars purchased by a series of 3 customers. The probability that a randomly selected customer purchases a new car is 0.2. So how many customers do I have? We have 3 customers. So what are the possible outcomes of them buying a car? How many cars out of 3? So let's write all the possible outcomes. 3 people go to a lot. Could none of them buy a car? Sure. So one possible outcome is that 0 cars would be purchased. What's another possible outcome? That 1 would be purchased, that 2 of the 3 people will purchase a car, or that all the people will purchase a car. So you agree that those are all the outcomes that would exist here. Okay? Now how do we come up with the probability of each of those? If any one person purchases a car, we have 0.2. Doesn't that kind of like a slot diagram situation? So what would no cars? Wouldn't that be 0.8, 0.8, 0.8, 0.8? The first person didn't purchase a car. The second person didn't purchase a car. The third person didn't purchase a car. You with me on that, what I'm saying? Okay. So it's just going to be 0.8 to the third power. Sorry. Now we have to make sure that we realize they're independent events. The fact that Jasmine didn't buy a car has no bearing or any dependency on whether I buy a car or whether or not Temerson buys a car. We're all independent events, okay? So I would have to tell you that. What is 0.8 to the third, by the way? 0.512? All right, fair enough. How about if 1 person bought a car? That means 2 people did not buy a car, but 1 person did buy a car. So what would that be? 0.2 times 0.8 to the second. Would you agree with that? Okay. Do I have to worry about the order?
Yeah.
Let's see. Maybe. We know a way to check ourselves and make sure that they all add up to be 1, right? So maybe we'll have to check these 2 again. We'll have to see. Possibly. What is that, by the way? Probability test. So 0.2 times 0.8. So 0.128. Maybe. I'm telling you there might be some more to it. This one would be 2 people did buy the car, so that would be 0.2 squared times 0.8. Would you agree? So 0.2 squared times 0.8. Maybe 0.032. And then I have all 3 people bought the car. That's 0.2 to the third. And that's going to be 0.008. There's a problem here, isn't there? I see a problem. What problem do you see? They don't add up to 1. So we know we're missing something. Are there any of those probabilities we know for certain are correct? 0 and 3. I agree. Because order doesn't matter in those cases. Do you agree? They all bought it or they all didn't. So I think we need to rethink these 2 here. We need to rethink these. Okay? So why do we need to rethink them? How do we rethink them? What can we do to change it? Little slots. Let's try that. So we know that if 1 person bought the car, that person can be the first one, it could be the second one, or it could be the third one. Would you agree with that? So we would have, I'm just putting in my slot, to call it a slot diagram. So it means that the first person bought the car. That means the second one didn't, the third one didn't. Okay so far? Or it could be the second person that bought the car. Or it could be the third person that bought the car. So what we'll need to do is we'll need to plug all of this in to see what distribution and they don't add to 1, that probably means order matters. Okay? And that's exactly what we figured out here. So someone go ahead for a second and multiply those together and tell me what the probability of 1 would be. So 0.384. I'm just going to write it above it, if that's okay, just because I don't have any room underneath anymore. That's the probability. All right, let's think about number 2, or number 2, so an outcome of 2. Again, we have 3 customers. So I'm just going to kind of do the same thing like I did before. But this time I'm going to fill them in with 2 people bought the car. Well, it could be the first 2 people, and the last one did not buy a car. It could be the first and the third, and the middle one did not buy the car. It could be the last 2 people that bought the car. Are there any other possible combinations? There's just 3? I think that's it, isn't it? Okay, so let's see what this one would be. This would be 0.2 squared times 0.8. Oh, really? Really? Did you get 0.096? Hopefully that's what I got too. Now let's make sure that these all add up. Do they all add up to be 1? 0.512, 0.384, 0.096, and 0.008. Double check me. They should add to be 1. I didn't add is what I did wrong. I multiplied, okay. Does it add to be 1, guys? Okay, double checking. But that's always a good thing to... There's 0.008. I didn't say that. Yeah, having a calculator issue. It does add to be 1. All right, so we know we've done it correct. Would you agree with that? We feel comfortable, we feel certain. We've created our probability model. Excellent. On a test or a quiz, or on Wednesday, on your test, I'm going to give you a situation like this where you have to fill out probability distribution. Maybe I'll give you 1 or 2 of them and ask you to find the missing one. So that's possible too. Okay? Tanner, if I close your eyes again, I'm going to call you out. And you're going to come sit in the front and do some fun tests. All right. You can both talk. Okay. Now, this is what we came up with. We figured out what our answer was. Now, we also talked about during that supplemental period last time that expected value and mean are the same thing. I'd like us to practice making sure we know how to do it by hand and verify it on the calculator just to kind of refresh and remember. So how would I find this by hand? If I wanted to find the expected value or the mean of this distribution, what would I do? Go ahead, Brenda. Tell me to use the numbers. Okay, and then what am I going to do after that? Okay, so that's what the sum means. Very good. It's the outcome times its probability and the sum of all of them. So, and then I'm going to go ahead and continue on that path here. Plus 2 times 0.096. And this is exactly what we did last class. Or, shortcut-wise, if we ever want to check our answers, do you remember what we did? So where do I get to the L1? Stat edit, good, okay. And we'll plug into L1 our what? Our outcomes, our X's, 0, 1, 2, 3. Excuse me. And then in list 2, we'll put our probabilities. All right, and now what? Stat, cal. One more stat. What do I have to make sure? The frequency should be L2. Very good. Those are probabilities. Exactly. And so our our mean or our expected count, our expected value here is 0.6. Okay? So we have 0.6. What would our standard deviation be if you were ever asked? 0.693. 0.693. Excellent. So 0.693. Don't forget your units. What was the context of the situation? number of cars that were being sold, right? So how many cars out of 3 people, when 3 people come to the lot, how many cars do I expect to be bought? About 0.69 of a car. So would I have to sell more? I'd have to have more than 3 people come to the lot to expect to sell my first car. Would you agree? Okay, so we're going to go ahead and say cars here as our unit. So we're in context, okay? So for every 3 people that come to the lot, I can expect to sell 0.693 cars. Okay. So we know this. That's what it means by interpolance. That's what I would want you to say. Exactly. Okay. All right. That's really all I'm going to ask for you in terms of probability distributions. Can you go ahead and write all the possible outcomes? Can you fill in the probabilities? Can you find the mean and standard deviation? That's all you'll have to do on the test. Okay? So are there any questions about it right now? I would want you to, if I was asking a situation like this, I would want you to show me how you got the answers. Okay? Yeah. Now, if I said just find the expected value and mean, and I don't say show work, give me an answer. Say 0.6. If I say using the formula, I want you to show me the work. Okay? So just be clear, just read the question. If it says show work, then I mean it. Okay? All right. So let's talk about what's going to be on this test, shall we? If you want to go ahead and take out your notes, or this is part I would write down if I were you. What is going to be on Wednesday's test? We're going to call it the probability test number 1. Because you will have another probability test that will cover normal distributions, binomial, and combining random variables. You'll have a probability test 2 in January after the winter break. But on this test, you can see you're going to be doing the addition formula. What is the addition formula? What do I mean by that, by the way? Or B, right? So it's a probability of A, and you have this on your formula sheet. You're totally fine. You can use your formula sheet on the test. You don't have to memorize these, okay? So the probability of A or B is equal to probability of A plus the probability of B minus the probability of A and B. Yeah. So this is what, if I ever see the word or, I would expect you to think about this formula. So that's the key word, right? Key word being or here. All right. You can also expect to see, I'm going to say the multiplication rule. The multiplication rule is going to be with, they would have to be independent events. If they're, the multiplication for independent events. Independent events is just probability of A and B is equal to the probability of A times the probability of B. Do you agree with that? If they're independent. Now, oftentimes they're not independent and they're conditional, right? So if they're conditional, how does this change? The probability of A and B. Look at your formula sheet if you're not familiar. The probability of, get your formula sheets out if you're not sure. This one's on your formula sheet, right in the middle. Anyone have it handy? What is it? I'm sorry. It has their formula sheet. So everything has this right here. So it's right here, right? Just rearranging this. So it's not really a division, is it? It's going to be the probability of, look at this right here. The probability of A getting B times the probability of B. Right? And remember, if they are independent events, aren't these two two things equal to each other anyway, right? It's kind of the same formula.
So can I just write that formula down as like a given?
Yeah. It's always really this one. We just have to replace that with A if they're independent events. That's exactly right. I don't really like to treat them as two separate things anyway. Okay. What if I see the word both as a key word? What does that tell me that I'm going to be doing? The diagram, good. You're also going to need to look at some contingency tables, kind of like on the quiz that I just handed back to you. Can you use a contingency table to come up with some conditional probabilities and things like that? Is that like a howling or something? Like, was that some sort of like wolf, like in another room? Did y'all hear that or is that just me? Sure. All right. Then we have tree diagrams is another strategy that we've done already as well. What really tells me that a tree diagram is a strategy I should use to solve? Multi-stage, we had two different things going on at one time, kind of like on the quiz where you had grade level, freshman, sophomore, junior, senior, or whether or not they were humanities major or not. So we have multiple things going on. Tree diagrams are a good strategy. I will tell you, you need to know what disjoint means. What's another word for disjoint? Mutually exclusive. What does that mean exactly? They both can't happen at the same time. In other words, the probability that they overlap is 0. Right? You can't have A and B. You also need to look at knowing how to prove that something is independent. Just kind of like, well, and by the way, these two are totally not the same thing, right? They're not the same thing. Independent is that one doesn't affect the other, kind of like we looked at the quiz as well. A given B is the same as A. That's kind of what we would show here. I'm trying to think, I just made a test up. I'm trying to say, trying to decide, is there anything else that you would have to do? I mean, the slot diagram. I mean, both quizzes are, I think if you study quiz chapter 14, chapter 15 quiz, the probability practice, and then the practice test I've given you, that's really all you need to know. You should know what the probabilities are always between what and what. 0 and 1. If you ever have a probability over 1, something's wrong. It can't happen. And then I guess I need to put up here the probability distributions, right? Because that's the last thing that we kind of looked at. Any questions on credit? Okay, that's fine. So knowing this, I know Brenda wanted to look at something on the test, the practice test. No problem. Definitely going to do that. Is there anything else before we jump to that that kind of jumps out at you? That, like, you know what? I really want to go over this one thing one more time. Anything that jumps out at you that you'd like to see? I'm going to give you some problems in the textbook to practice and to review. Some will be odd, some will be even, so you can look at the answers in the back, and that's fine. Maybe I'll just pick odd numbers, because I don't want you to go home and not know what you're doing. Would that be better if I pick all odds? That way you can check your answers. Just check them. Don't just write the answers. Zachary knows who will show your work, right? Nothing that jumps out at you.
Can we go over independence events a bit more? Just like how you can
Absolutely. I want to solidify that in your brain, right? No problem. Okay. Is there happen to be one of the practice tests that's independence? Do you know, Brenda? Let me grab my practice test real quick and let's look at that. Could you grab yours as well? Let's look at it. Okay. So let's look at it. Let's look at the probability practice test and see if there's one that talks about independence. part of your homework. Okay? You listening, Emmy? Okay. So question 2 on the probability practice test, you need to now do. I'll write it on here. Ooh, that was fun. Because if you read, go ahead and read that problem for me for a second, and I want you to tell me what strategy. Am I using the addition formula? Is it a conditional? Am I doing a Venn diagram, a tree diagram? Is it an and or combo?
Tree diagram. She was asking if you needed a copy.
Thanks, Daniel. He's right. I already handed them all out.
Gee, there you go.
Is that okay?
Yeah.
I call it sarcasm.
But it's not always sarcastic. It could be like.
I mean for it to be sarcastic. But they always say teachers shouldn't be that way. People take it the wrong way. Okay. Number 2, it does say draw a tree diagram, but can you read it and tell me why you should? Huh? It's not written on here though. Okay. It is a disease testing problem, you're right. Okay, if you would, problem number 3. I'm giving you a probability distribution. I want you to find the expected value and the standard deviation. Notice it says variance there. Do you see that in question 3?
Yeah.
Okay. All the variance is the square of the standard deviation, right? Just take your standard deviation as a square. That's your variance. Problem number 4 is a probability distribution question. That's one that I would expect you to be able to figure out. That's just like the problem we just did. Okay? I'm going to tell you that order is going to matter. Okay? So be careful with that. You may cross off number 5. You can circle it. That will be on the next unit test. It's not on this test at all. You can I cross mine off. You may cross yours off as well. Number 5. And then I think that's all I had you skip. Is that correct? You started back up with question 6, right?
Yeah.
Okay. So let me see if there's an independent one. Oh, question 9, did I tell you to do? Yeah, we did 9. Okay, good. Oh, here we go. Number 10. Explain the difference between mutually exclusive and independent events. All right. I would rather. Yeah, we did. I'm just trying to show. Someone asked a question about it. Can we look at number 11? This will kill 2 birds with 1 stone. Number 11, because Stephanie wanted to look at some contingency questions too, and then I think we can decide whether or not we can answer the independent question here too. So let's look at number 11.
After this, can we look at number 8 on the most exploited?
Absolutely. I'll go over all the multiple choices in a minute. Let's look at number 11 first. Okay. So I want you to go back and do questions 2, 3, and 4. Okay? All right, let's look at number 11 now. So in question number 11, you have either answered the question yes or no, and you are either in grade 10 or 11. Would you agree with that? That's what the chart's giving us here. So we have 7, 8, 9, 12. And then I always like to include a total column for everything and a total row. So we'll do that as well. So we have 15, 21, 16, 20, and 36. You should include those as well, okay? So this is a contingency table. So this is one just like you would see on a test or the quiz that we just saw too. Let's answer these questions. What's the probability that they're in grade 10? So in grade 10, what am I looking for? So it's the probability they're in grade 10. So let's rewrite that. Tell me what 2 things I'm going to divide. What by what? 15 divided by 36. Good. And you can leave it as that fraction, or you can give it to me as a decimal. It's 0.4167. 0.416 repeating. But grade 10 is the total of grade 10 divided by the total total. We know this. Answered yes. What's that one going to be? 16 15 divided by 36, so we know that. And that one is just 0.4 repeating. All right, keep going. Is in grade 10 and answered yes. So 10 and yes. What's that one? 7 divided by 36. Very good. And I do like showing that step. Show me what you're dividing. Don't just give me straight decimal. So 0.194 repeating. Good. Who is in grade 10 answered yes? What is that? That's a given, that problem. So which way does it go? So I'm going to say it again. Who is in grade 10 answered yes? Yes comes first, and then given 10. So if you have a contingency table, you can just use it, or you can use the formula, either way. The probability of yes and 10 divided by the probability of 10. Or you can just use what you have here. So it's yes and 10 divided by 10. So it's 7 divided by 15. Would you agree? And I have 0.46 on that. 0.467. Oh, yes. Sure. Thanks for asking, sir. All right. And then we said who answered no is in grade 10. So what would that one look like? We know it's a given that. I agree. Let me read it again one more time. Who answered no is in grade 10. So which one comes first? 10 comes first. So we have 10 given no. And so that's going to be 15. No, I'm sorry. 8 divided by 20. You guys get that? Yes or no? That's wrong with my finger. Make sure I have that right. Divided by the totals of no's, right? That's right. So 0.4? So, Stephanie, does that help a little bit? So what I'd like to look at now is the idea of independence. So the question I might ask at this point is grade level and how you answer the question independent of each other? So is grade level independent of how you answer the question? So what could I do? Rather than try to recreate the wheel, maybe we should look at some of the answers that we've already come up with. We have a couple of conditionals here. We have the probability of yes given 10. What would that have to equal if we were talking about independence? Probability of yes. So we would compare these two. So 0.4 repeating, 0.46 repeating. They're kind of close. So is that enough? Well, maybe we should look at another one just to see. So could we compare the probability of 10 and no? I'm sorry, 10 given no. What would we compare that one to? Probability of just 10, which is this one here. What do you think about that? 0.416 repeating to 0.4. They're pretty close. So I think because of this, that they're probably independent of each other. I think they're close enough. Now, you could say that 0.4 does not equal 0.416 repeating and say they're dependent. And I would still accept it. Because all I'm looking for is, are you comparing the right two things, and do you know that they're supposed to equal each other to be independent, and they're not equal to each other to be dependent? So it's kind of like back up your argument with your explanation. So, just answering yes is not enough. So what I would say is this. To be a complete full credit answer, the probability of 10 given no, does that equal probability of 10? And we would say 0.4 equals 0.416 repeating. And I might put a wavy equals there. Okay, and I would say because the probabilities are close, I might even say relatively close, they're not exact. showed the context, I showed the numbers, and now I'm writing a sentence. Because they are relatively close, I believe grade level itself, grade level, and how they answered the question, was answered are independent. Maddie, is that helpful? You're very welcome. Yes, sir.
What would you consider close enough?
I know. What is close enough? That's the question. I would say if they are a tenth off is too far for sure. I might even say like several hundredths off might not, might be an issue. Anything more than a tenth, definitely not. But 0.4, 0.42, 0.4167, pretty close. So, in my mind, now again, if you said that they're not equal and they're dependent, I would give you full credit. Okay? Yes, they would. Okay. But that's why I'm teaching you this way. What they're looking for is, can you contextually tell me what you're trying to do? Can you show me how you got your numbers? And can you come up with a summary sentence? Yes. Okay? That's what you think. They're not going to give you anything that close and make you decide. They'd either be really far off or they'd be almost exact. There wouldn't be any gray area. How do we feel about the tests and what's coming up and what we're going to hit here? Anything else I can answer for you? Tanner, jump jacks on. Come on, get it together. Come on. You what? Okay, then you need to wake up. Let's splash water on your face. Do something. Okay? Is there anything else I can answer for you, Brenda? Oh, multiple choice. You're right. Thank you. Multiple choice. Let me just read the answers really quickly, please. You ready? On the practice test, here are the multiple choice answers. Number 1 was B, 2 was E, 3 was D. Number 4 was E, 5 A, 6 C. By the way, 6 you don't need to know how to do. 7 you don't need to know how to do. We'll do binomial and geometrics after winter break. 8 you don't need to do. I think I might have told you that before. We're going to get to those eventually. So 6, 7, and 8. Did it end? It stopped at 8, right? Number 4. Sure. So just 1 through 5. All right, let's look at number 4. All right, so it says according to a National Telecommunication and Information Administration, 56.5% of U.S. households owned a computer in 2001. I think that has probably grown exponentially since then. It's number 4 on the multiple choice. Okay? What is the probability that of 3 randomly selected houses, at least one owned a computer in 2001? This is actually a binomial situation, but that's okay. So we know that at least one, we have a whole bunch of different scenarios. If you want the probability of at least one, what did I tell you that we could do? That's the same thing as 1 minus the probability of none. Would you agree with that? Isn't that what I told you many times over, right? So we want to find the probability that none of my 3 houses had a computer. So let's find that. The probability that none had a computer would be the first one didn't, the second one didn't, and the third one didn't. So what's the probability that they didn't own a computer? What's 1 minus 0.565? 0.435? So the first one didn't have a computer, the second one didn't have a computer, and the third one didn't have a computer. Would you agree with that part? So what is that? 0.35 to the third power is 0.0283. That's the probability that none of the 3 households had a computer. I now need to subtract it from 1 to figure out the probability that at least one had it. So 1 minus 0.0823, and that would give me 0.918, which is letter D. Is that helpful?
Yeah.
You will definitely see that on the test. Okay, definitely. Yes, ma'am.
Was that the same formula for question 8 and 9 as the previous one?
Okay, let me look. Yes. Well, yeah, for 9 definitely, because you have to find the none probability first, and then you have 1 minus that, figure out the, right? And it's probably that 1 or more, so that's definitely, I agree. 8's a little bit different. Did you want to look at 8? By the way, 9C, you don't need to do that on the pre-response. 9C, did I tell you that already? Cross that one out, 9C. All right. Last one that I've been asked to do is question 8 on the probability practice test. I'm running out of time here. It says a string of Christmas lights contains 20 lights. I've been dealing with this at my house. One goes out, they all go out. All right? Each light has a probability of 0.02 failing. Okay, the probability that it burns out. What's the probability that it will remain bright for the 3 years, meaning that the entire period? So it means that they all stay bright. So that they don't fail, and all 20 of them, so 0.98 times 0.98 times 0.98 20 times. There's like 20 slots. And I'd rather than just do it times, put it times 20 power. So you get 0.60. That would be the answer. Okay? Okay. Let me give you your homework. Obviously, you need to do those 3 problems that I told you to on the practice test. So I am looking for, where did I write that on? Hopefully I wrote it down somewhere. Here we go, right here. So, part of your homework, folks, is this right here on the probability practice test, questions 2, 3, and 4. And then I would like for you to do some review. So starting on page 402. This is the review. This is the probability review. I'm going to pick a few problems here. Okay. So I want you to do problem number 1. I'll try to pick odd ones. Let's have you do 21.